Ever wondered how Amazon or FedEx orchestrates thousands of deliveries every day with near-perfect precision? It's not magic. It's a computational beast known as the vehicle routing problem, VRP. This isn't just a logistics puzzle, it's a mathematical nightmare. VRP is NP-hard, meaning the complexity explodes exponentially with each additional stop. Traditional methods rely on human-crafted rules, like always prioritize the closest customer. But what if we could let machines learn the optimal strategies instead? Let's break it down. VRP isn't just about minimizing distance, it's a multi-objective optimization challenge. You're balancing fuel costs, time windows, vehicle capacities, and real-world chaos. Think traffic jams, weather, or last-minute order changes. Solving this perfectly is computationally infeasible for large-scale scenarios. That's where this study shines. It leverages machine learning to identify which features of a route most strongly correlate with success. Here's how it works. The researchers trained models on thousands of simulated delivery scenarios, teaching them to recognize patterns. Imagine a detective analyzing clues. Is the distance between stops a red flag? Does the distribution of customers hint at inefficiency? The model doesn't just guess. It learns which factors consistently predict good solutions. But here's the breakthrough. They didn't stop at one model. They tested multiple architectures across diverse environments, urban grids, rural sprawl, fluctuating demand. Why? Because VRP isn't a one-size-fits-all problem. A route that works in a dense city might collapse in a sparsely populated area. By evaluating features in these contexts, they uncovered a hierarchy of importance. For instance, in time-sensitive scenarios, average route length becomes critical. In rural settings, customer density might be the linchpin. The team even developed a novel metric, a feature prioritization score, to categorize clues as critical, green, context-dependent, yellow, or irrelevant, red. This isn't just theory. It's a roadmap for optimizing metaheuristic algorithms, the workhorses of modern logistics. Why does this matter? Metaheuristics like genetic algorithms or simulated annealing thrive on guided search. By highlighting which features to focus on, this research allows these algorithms to converge faster on near-optimal solutions. Picture real-time route adjustments, a truck rerouting around an accident, or a fleet dynamically balancing loads during a surge in orders. This isn't speculative, it's the future of adaptive logistics. So next time you track a package, remember, behind that simple update is a symphony of math, machine learning, and relentless problem-solving. This study isn't just about better routes, it's about redefining how we approach complex, real-world optimization. Thanks for watching. If you're hungry for more deep dives into AI's role in logistics or other domains, hit that subscribe button. And drop a comment. What other NP-hard problems do you think machine learning could crack next? Until next time.